All right, how's everybody doing out there, Math Magic Land? That's right, this is Miss Muscarella, Musky, coming at you again. And we're going to finish up using values around the unit circle. Using the unit circle, this is going to take a look at examples 7, 8, 9, 10, 11, and 12. So, all right, so let's just kind of review real quickly the first 6 examples. All right, so those are our values. And remember, the unit circle, we've got a radius of length 1 unit. X-coordinate represents cosine, and Y-coordinate represents the sine. And then the red values in the unit circle diagram I have here are, of course, the values for tangent. Now, the reciprocal trig identities. So these are going to be some formulas that you're going to have to know and be comfortable with, as well as the reciprocal values to memorize. Like, get those down, put those in your memory bank, and totally memorize them. Now, sine, its reciprocal is going to be cosecant. So, cosecant of theta and sine of theta are going to be reciprocals. So that's one of the relationships that we want to know. So those are going to be reciprocal identities, sine and cosecant. And just like sine and cosecant, we've got cosine and secant. They are also going to be reciprocal identities. So if we know what secant is, then we can find its reciprocal to find the cosine, and vice versa. Now, tangent and cotangent, they're always the easy ones because they pretty much sound like one another. So tangent would be 1 over cotangent, and again, don't forget the theta, and then cotangent's reciprocal would be 1 over tangent of theta. So those are going to be those values. Now, when we look around the unit circle, okay, we're going to be dealing with the x and y values, or the tangent value of sine, cosine, and tangent. We're going to be looking at the coordinates or the relationships there. And sometimes we've got to take the reciprocal. If you take the reciprocal of 0, okay, so let's just kind of do this on the side here for a second. If you had 0 right here, and it's reciprocal, so then you know 0 would be on the bottom. Anytime you have 0 on the bottom, that's not good. No. So this is what is going to be undefined, right? So anytime you have something that's undefined, the reciprocal of undefined will be 0, and vice versa. The reciprocal of 0 will be undefined. So make sure you understand that those relationships and how they are tied together. Same thing with 1/2. If you take 1/2 and flip that, the numerator goes to the denominator goes to the numerator, you'll end up with a value of 2. So you have to understand the relationship between 1/2 and 2 and that they are reciprocals. Now, when you work with the ones that have radicals in the numerators, these ones are going to be a little bit more involved because there's going to be a couple of steps here. So our first step, of course, some people will, I want you to be able to get to do this in the head. So we'll do the first one a long way. If you take the reciprocal of square root of 2 over 2, so square root of 2 over 2, their reciprocal, 2 would go on the top, and then square root of 2 would go on the bottom. But again, you've got to rationalize that. So we would have to multiply by square root of 2 over square root of 2. We know the denominators are just going to give us plain old 2. In the numerator, we would have 2 square roots of 2. And then, of course, our 2's would cancel out. So our final answer is going to just be plain old square root of 2. All right, so that's one I want you to memorize. You don't have to show all of this stuff in the middle. You just have to know that square root of 2 over 2 and the square root of 2 are reciprocals. Now, when we have this for square root of 3 over 2, again, we're going to go through that because if you flip that, you'd get 2 on the top, square root of 3 in the denominator, and then when you take the reciprocal of that, and I'm going to do this in one step now instead of 2, when we do that, because this one's pretty straightforward, you'd have square root 2 square roots of 3 on the top, and then 3 in the denominator. Now, square root of 3 over 3 is going to be very similar to how square root of 2 over 2 went. So if you think you got that one just works out to be square root of 2. So notice in this pattern here, you have the same number underneath the square root as you do in the denominator. And notice how that answer comes out. That answer is just going to be a square root of whatever the number was under the denominator, bro. So in this case, right, we got square root of 3 over 3. The number underneath the square root is 3, which means our final answer will just end up being square root of 3. That's it. Bam, boom, diggity, done. So these are going to be some reciprocal trig values I want you to memorize, as well as the reciprocal trig identities, because we're going to need those as we apply them here for these pieces. All right, so we'll be using those shortly when we find these values coming up next. All right, so thanks for watching this one. Be sure you tune into the next one to evaluate the 6 trig functions that you see here. All right, I'll catch up with you guys later. Peace out.